Hey guys, Ketan again. Today we are solving another problem from the beginner level of CodeChef in C++. And the problem we are solving today is Mahasena. And the problem code is AMR15A. Katappa, as you all know, was one of the greatest warriors of his time. The kingdom of Maheshmati had never lost a battle under him as army chief. And the reason for that was their really powerful army, also called as Mahasena. Katappa was known to be a very superstitious person. He believed that a soldier is lucky if the soldier is holding an even number of weapons, and unlucky otherwise. He considered the army as ready for battle if the count of lucky soldiers is strictly greater than the count of unlucky soldiers, and not ready otherwise. Given the number of weapons each soldier is holding, your task is to determine whether the army formed by all these soldiers is ready for battle or not. Not ready. You can find the definition of an even number here. Okay. So first of all I would like to clear up what is an even number. So let's just explore this link. I hope you all know what an even number is. An even number is an integer that can be divided by 2 and remain an integer or has no remainder. Right? It's as simple as that. If a number is divisible by 2 without leaving a remainder, then that number is called an even number. Otherwise it's called an odd number. Right? And it starts from 0. 0 is an even number, 2 is an even number, 4 is an even number, and so on. 1 is the first odd number, 3 is the second odd number, and so on. Right? Okay. Now since that is clear, the input will be in this format. The first line of input consists single integer n denoting the number of soldiers, and second line contains how many weapons each soldier is holding. Okay. Right, let's start with coding, and I'll explain in the way how to do it. Okay, let me just take the input first so that we can talk about the problem a little bit more. Okay, this is just for test cases, but since we are not taking test cases, we can actually use it as the n value, because we need a loop here, because we'll be given an array of numbers, like a list of numbers, which will be the number of weapons each soldier is holding, right? So let's take in n, and while I is less than n, we can actually store all these numbers in an array and then process it, or we can just process them directly, because we don't have to use the array again. Like, we don't need the numbers after we have used them once, right, in this specific problem. So I'll just be using them once. That means I'll be taking them as current soldiers weapons, right? This is too long variable name, so let's just shorten it to CSW, which stands for current soldiers weapons, right? And it is given in the input one by one. So let's take it CSW, right? So one by one we are taking the current soldiers. Let's use this example so that you can understand better. So first n value will be 4, and then in the loop first we take 11 as an input, so we'll get CSW equal to 11, right? This is the number of weapons the first soldier is holding. Okay, now we just need to check if it is even or not. First thing, how do we check it? We have to see if it is divisible by 2. We check if something is divisible by something else. Let's say A is divisible by B or not, by using the modulo operator, right? If A is divisible by B, it will give us 0. Now we are checking if CSW is divisible by 2, because we are checking if it is an even number or not, right? So we'll check for divisibility with 2. So if it is divisible by 2, then it is an even number. Okay, so what happens when it is an even number? We consider that soldier to be a lucky soldier. So we have to keep a count of how many lucky soldiers there are. So along with n, we'll also need lucky. Okay, so lucky is actually 0 at first, because we have before saying any soldier we can't say if he is lucky or not, right? So when we see that a soldier has even number of weapons, then we increment lucky by 1, right? Okay, which means that we have added this soldier as a lucky soldier. Okay, now that's all we need right now, because we only have to count how many number of lucky soldiers there are, right? Because we have total number of soldiers and we have lucky how many lucky soldiers are there. From there we can get the unlucky number of soldiers, right? Okay, now we just need to check for this condition, which is if lucky soldier is number of lucky soldiers is strictly greater than the count of unlucky soldiers or not. Okay, now that condition is out of the loop, because we just processed all the soldiers and then we are checking if the battle if the army is ready for the battle or not. Now if lucky is greater than n divided by 2, why am I doing n divided by 2? Or actually, yeah, if lucky is this shouldn't be used. If lucky is greater than n minus lucky, right? So let's say we have 10 soldiers and lucky equals to we have 6 lucky soldiers. Then how do we get the unlucky soldiers? Unlucky soldiers equal to 10 minus 6, right? Which is total number of soldiers which we are storing it in n, and then number of lucky soldiers, right? That's what we are doing here. Now we are checking if number of lucky soldiers is greater than unlucky soldiers, and if that is the case, it has to be strictly greater. They mentioned that it is strictly greater, right? Strictly greater. So we are using only the greater than operator. If it is the case, then we output ready for battle, right? Okay, else we output not ready. Okay, now we just need to write one more line. This is just formatting for the output to get into new line, right? Actually we don't need it because we don't have test cases. Okay, we don't need cout end line because we don't have test cases. So let's do one test case and let's see if it works. This is diverse, so let's use this test case. Not ready, and the answer is not ready, right? So it is working. Let's submit this, and in the meantime let me talk about the time complexity and space complexity. Okay, we are using only one loop here, and that loop is running n number of times, right? This is just a if condition, so it will only amount to 1 unit of time, and we got the correct answer, so it's working. And this loop will take order of n time to run through. So that's it. Like all else are if else conditions, right? So the time complexity of this thing is order of n. Okay, and then what's the space complexity? Are we using an array? We are not using an array to store the values, right? Because we don't need access to the values after we have processed them once, right? So we are not even storing them in an array or any collection. So the space complexity will just be order of 1, because we know how many there are only constant number of variables in the program, so we know how many variables are there. So it will be order of 1 space complexity. So time complexity is order of n, and then space complexity is order of 1, right? This can't be reduced any further, because we have to go through each value to decide if it is even or not, right? So that's the best this is the best possible solution for this, right? Okay, thank you guys. Subscribe and hit the like button, and share it with your friends if you think it will be helpful for them.